Okay, so last week we started talking about polygons and polyhedron. Who can tell me the difference between a polyhedron and a polygon? Maya? Yeah, a polyhedron is 3D, a polygon is 2D. Who remembers the criteria for a flat 2D shape to be considered a polygon? Cam, give me one. Okay, it's a closed 2D figure. Made of line segments, which means what? No curves. Parker? I said a 2D. I said 2D. So I said flat, closed shape, made up of line segments. That means not curved that. Cam? Only cross at the endpoints. Okay? So that's a polygon. Polyhedron's the 3D version of that. So our circles are out. Anything with circles is out for now. You guys will talk about those more in the upper grades. So we also talked about faces, bases, vertices, and edges. Let's focus 3D figures. What is a face of a 3D figure? Emmett? It's all of the flat sides. Yep, all of the flat sides are considered faces. Then what are bases, Maya? Sometimes it's one side, sometimes it's two. It depends if we're talking about a blank or a blank. Who can fill in those blanks? Nope, they're all 3D shapes, 3D figures. Some of them have one base, some of them have two bases. Kinley? Not any other. So she said a pyramid has one base. She is correct. Remember, those have triangle faces when we look at it because they all come to a point. What's the other type? Cone. Not a cone. We don't talk about cones this year because it has a circle. Emma? Prism has two bases. What shape are the faces of prisms? Rectangles. Good job. Okay, and again, we're going over all this because it's a lot of information, and that's what we're practicing today. What is a vertice on a 3D shape? Kanan, how can I find the vertices on a 3D shape?
Just look for all the corners.
Yeah, I look for the points, the corners. Okay? What about edges? Are you guys short one?
Yeah,
Are there two there? Edges, Paxton?
like where the faces meet.
Where two sides meet. Yeah, where two faces meet. And remember, in this room, around the top edge, 1, 2, 3, 4. Around the bottom edge, 1, 2, 3, 4. But there's 4 more. Where are the other 4 edges, Briley? In the corners, going from top to bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nope, we already counted those. 4 around the top, 4 around the bottom, 4 from top to bottom in the corners. 4 times 3 is 12. Okay, so what we're going to focus on today is naming the shapes. When you are naming these 3D figures, I have to get to the same picture as you. When you are naming the 3D shapes, the first thing you have to decide, is it a prism or is it a pyramid? Logan, how do I decide if a shape is a prism or a pyramid? What's the difference? Who can answer that? Difference between a prism and a pyramid. Reese?
A prism has 2 rectangles on the side.
I'm not going to say that because that's not always true. There's something that's always true. Cam?
Pyramids are on up and down, prisms are side to side.
Nope. Briley?
The prisms only have one base and prisms have 2, or can be any of them can be a base, and then
She's partially right. You're mixing it up. It's something to do with the bases.
The pyramids only have one base?
Pyramids have one base and prisms have 2. So when you are trying to name a 3D figure, first see if there are 2 bases or 1 base. That tells you if it's a prism or a pyramid. To get the rest of the name, you look at the base shape. If the base shape is an octagon, then it's an octagonal prism or an octagonal pyramid. If the base is a triangle, then it is a triangular prism or a triangular pyramid. Squares, they get different names, but you could call it a square pyramid or a rectangular pyramid, a rectangular prism, or a cube if it's all squares, okay? That's what we're going to look here. So if we're looking at these 3D shapes, notice out to the edges. What do we call those things, out to the edges? Who remembers that word, Lori?
Net.
A net. What is a net, Avery? Emmett?
It's where the shape is like taken apart.
Yeah, it's kind of like we had a 3D shape and we unfolded it and made it a flat shape. So it's really turning a 3D shape into a flat shape. Sometimes that helps us visually. If I had to guess, Kanan is going to be really good at the 3D shapes because he's very artistic. You have to have good spatial reasoning. When you look at a shape, you have to be able to kind of visualize the net. That will make it easier for you when you're finding surface area. Who remembers what is surface area? Dominic, do you remember that? What is surface area? Parker?
It's the area of a flat surface.
Almost, because that could be like, you need a little bit more there. Kinley? Yeah, it's the area of all the faces and bases added together. So if it was unfolded into a net, then it would be the area of all of those flat surfaces. But on a 3D figure, whether it's a net or the 3D figure, you have to find the area of all of the sides and add them together. It's the total area of all the surfaces. Okay, so we're going to kind of dissect some of these shapes. For a cube, okay, we have a cube here. We're trying to figure out the number of edges, vertices, and faces. On a cube, let's look at it. How many edges are on the top? There's 4 edges on the top. So that means there are how many on the bottom? There's 1, 2, 3, 4 on top, 4 on bottom. Are there any others?
No. Yes.
Where else, Emma? Yeah, there's 1, 2, 3 that I can see, but is that the only 3? Where's there one more? Kendall? Well, we already counted. So we said 4 on top. So that means there's 4 on bottom. I can only see 2 of them. So that's 8. 9, 10, 11. Are there only 11?
No.
Reese, where's there more?
Like on the back side.
Yeah, just how we assumed that if there's 2 here, there's 2 more on the back. There's 1 more back on that back side that I can't see. So how many edges are there all together? 12. So next to cube, right? 12 edges. Vertices. Paxton, what's a vertice?
A corner.
A corner. How many corners are on a cube? Do you have that first one down? Brant? 8. Because there's 1, 2, 3, 4 on the top, so there also have to be 4 on the bottom. So there are 8 vertices. Faces. How many faces does a cube have, Maya? Nope, not 2. Callan? 6. This is all of the sides. It has 2 what, Maya? 2 bases. We're going to add that in, so I have to make mine smaller again. So there are, oh, lost my dot. Right, 6 faces in that last box. I'm waiting for my circle to come back. There it is. So this is 12, 8, right, 6 faces, 2 bases. Does that mean there are 8 sides?
Mm-hmm.
No, 2 of those bases are the faces. Faces are all of them. Bases are the top and the bottom, or the left and the right, front and the back, whichever ones you want to call the bases. What shape are the bases and the faces in this case? If it's a cube. Square. They're all squares. Okay, whoever's humming, stop, please. Okay, the next one is a word that I left it in there. I didn't change it because I wanted you to see it. A cuboid. Okay, most people think that that means cube if they see it. That word shows up more in the upper grades, but it just means rectangular prism. So under cuboid, I want you to write rectangular prism. Okay, that is the most common 3D shape. Textbooks are rectangular prisms. Tissue boxes are rectangular prisms. Any box is a rectangular prism. Yeah, the smartboard, and it's not a perfect rectangular prism, but it is comparable to a rectangular prism. Okay, that is the most common. Most boxes that are shipped to you are rectangular prisms. These pencil boxes, rectangular prisms. They're not perfect because the bottom's a little bit smaller than top, but general idea, this is a rectangular prism. It's a 3D rectangle pretty much. Yeah, the boxes that the cards are in, the playing cards, are rectangular prisms. Okay, how many edges does a rectangular prism have? Remember, this room is a rectangular prism. Emmett?
4.
4 around the top, 4 around the bottom, and
8.
Paxton? 12. It's the same as a cube. Okay, a cube is just made out of squares. This one is stretched out a little bit. But there would be 4 around the top, 4 around the bottom, and then 4 connecting the top and the bottom. How many vertices? How many points, Lori?
8.
8. How many faces, Parker? 6. How many of those are bases? 2. So 6 faces, 2 bases. What shape are all of them, Reese? Rectangles. Even if the base is a square a rectangle? Yeah, so we can just call, if it's a rectangular prism with bases that are squares, we still just call it a rectangular prism. Cone, let's mark out because we're not talking about that this year. Why not? As circles. We let Miss Cooper deal with pi. Cylinders out. Why? Has a circle. What about a sphere? It's out. It's a 3D circle. Okay, now we're to square-based pyramid. Okay, this could be called a square pyramid. It could be called a rectangular pyramid. So let's mark out the word based because it could be called a square pyramid. I'm going to put or rect pyramid because it could also be called a rectangular pyramid. So this one we will have to visualize, or you guys might be able to look up at the top. I believe your rectangular pyramid is green at the top. So let's talk about edges. Edges. Focus on the base first. How many edges are on the base, Brant?
4.
So there's 4 around the base. There's 4 edges. Do you guys all agree with that? Where are there any other edges, Callan? Would that be an edge or would that be a vertice? Kendall?
Where like the line that makes a triangle?
Yeah, where the 2 face triangles, where the triangles meet, are there 4 edges? Yeah, so there's 4 around the bottom and then 4 up the side. What's 4 plus 4? 8. How many vertices are there, Avery, on that green shape? How many corners do you think there are? 5, because there's 4 around the bottom, and then where's the 5th one? At the top. So there are 5 faces. Faces. How many faces does it have, Kinley? 5. Why is it 5 faces and not 4? You have to count all of the sides for faces. How many bases, Cam? 1. Now, this one we're going to write a little bit different because what shape are the faces, Kendall? Triangles. What shape is the base? Maya? A square or a rectangle? I'm just going to write rectangle. So just by looking at the faces and the number of bases, we should be able to give the name. If the base is a rectangle and the faces are triangles, the triangles tell us that that is a pyramid, so it is a rectangular pyramid. Triangular prism. Looking at the top, who thinks they know what color shape are we focusing on? If I am looking for a triangular prism. Briley? The light blue. Why is it the light blue one and not the purple one? What is the purple one? Brant? Don't read that word because that's not what we call it. It is a triangular pyramid, because how do you know that it's a pyramid and not a prism? They don't focus on the number of sides, focus on the shape of the sides.
It only has one base.
Okay, or bases. Abby says it only has one base, but looking at the faces, what are the shape of the light blue one of the faces? Avery? That's the base. What other shape do you see? Rectangle, okay? The purple one is all triangles, which means the base and the faces are triangles. In the light blue one, we see a triangle and a rectangle. Anytime there's a rectangle involved, it's a prism, okay? Unless it's just one rectangle and all triangles. So, triangular prism. How many edges? Reese? 9. 3 around each base. So 1, 2, 3. And then down the sides. Connecting the bases, there's 3. Vertices. Vertices. How many points on there, Lori?
2.
Nope. Triangular prism.
1.
Paxton?
10.
Dom?
6.
6. 3 on each triangle. Those are the only points. 3 on each triangle. Faces and bases. How many faces does it have? Parker? 5. Good job. What? Bases. How many bases? How many of those faces are bases? Logan? We're looking at the light blue shape. We can only see 1, but is there another one? 2. Okay, what shape are the bases, Bryson? Triangles. And the faces would be rectangles. Now, when we're saying the faces are rectangles, are we talking about all of the faces? No. What did the video call them last week? Does anybody remember? If we're not including the bases, what we call those faces? Do you remember? It started with an L. The lateral faces, okay? When we're talking about the face shape, we're talking about the ones that are not the bases. That gets kind of confusing. Now, that would be like my Toblerone box, okay? A Toblerone is a triangular prism because it has 2 triangular bases, and if I hold it this way, all you see is rectangles because it has rectangular faces. Rectangle faces, triangle bases. 5 sides all together. 1, 2, 3, 4, 5. Tetrahedron. We don't call it a tetrahedron in 6th grade. We call it a triangular pyramid. Triangular pyramid. So that would be like this. The base would be a what? Triangle. What would the faces be? If this was a pyramid. Pyramid. Triangles, because they would come up to a point. How many triangles would come up to a point if the base was also a triangle? 3. So how many faces? Let's do faces first. How many faces would a pyramid have? 4. It'd have a triangle on bottom and 3 triangles going up to a point. So it would have 4 faces. How many of those would be bases? 1 base. What would all of the shapes be? Triangles. Edges. How many edges? There's 3 around the bottom. And then how many going up to a point, Kendall? 3 more. So what's 3 plus 3? 6. Good job. How many vertices? How many vertices? 4, because there's 3 around the triangle at the bottom and then 1 up at the top.
No, so long.
Okay, what I'm going to do next, you don't have these next pages, I didn't print them. We're going to look at different nets and decide what shape it is. Okay? We're going to look at different nets and decide what shape it is. So, how many faces are there? Lena?
Can I go to the bathroom?
If it's an emergency, go. I'll need a point. Kendall? There are 6. What shape do we see? We see 6 squares. What shape is made up of 6 squares, Callan? A cube. Thank you. Yeah, so that would be a cube. We're not writing this anywhere. You guys don't have this. I'm just going through some kind of what we have to think about. That one we don't do because it has a circle. Okay, let's look at this one. It has 6 different shapes. It looks like there's squares and rectangles. If it's 6-sided and it's made up of squares and rectangles, Parker?
It is a rectangular prism.
It's a rectangular prism. This one and this one would be my bases. And then these 4 would be the faces. Now, on a rectangular prism, there's usually sets that are the same. Like these 2 would be the same. In this picture, they all look the same, but that's not always true. Which 2 have to be the same? Because if we folded it up, which 2 would be across from each other? That's important to be able to visualize. Cam?
Sides.
Yeah, but which sides would be like, have to be the same? Abby?
The one.
Here, let me call them box 1, 2, 3, and 4. Which sides have to be the same? 1 and 3, because if I folded those up, that would be like the left and right side. So they would have to be the same. Kendall? And 2 and 4, because that would be like the top and bottom. So in a box, remember, like the left and right are the same, top and bottom, front and back. You have 3 sets of sides. Let's keep looking. What about that one? It's showing you how to fold it. So that extra space is to fold. Brant?
2 bases.
It has 2 bases that are triangles, and then what other shape does it have? 3 rectangles. So what shape has 2 triangular bases and then 3 rectangular faces? Avery? A triangular prism, because it has 2 bases. That's one of the giveaways. Prism, and you see rectangles. What about that one? Canaan?
It has 1 base.
It has 1 base that is a, okay, and it has triangular faces. So what could we call that shape?
Triangular pyramid.
Good job, a triangular pyramid. Getting rid of that one. We'll do one more. Reese, what do you think?
It looks like a star.
Briley, what do you think?
A square pyramid?
A square pyramid, because I only see 1 square. If you see 1 shape that's different, that has to be your base shape. All of those triangles would fold up into a point to make the pyramid. So yes, that is a square pyramid. Okay, I think I have to switch documents for the next one. Give me just a second. Yep. Okay, you guys go ahead and flip to your next page. I have to find my next page. I made your packet from like 3 different packets. I think, is that your next problem? Okay, so they give us a net on a grid, and they say find the area of the given rectangular prism if the area of 1 square is 1 square meters. When you do surface area, you have to show work for all of the faces. How many faces do we have here, Brant? 6. We are going to number them all the same. Okay, I'm going to call this 1, 2, 3, 4, 5, 6. Now, you do have to show work for all of the different faces, but how can you make your life a little bit easier, Cam? You can know which ones are the same. So Cam is telling me that 1 and 3, so I'm going to write 1 and 3, have to be the same. Why do they have to be the same, Cam? Because when you folded it up, those two would be on opposite sides, like possibly the left and the right. Or it could be the top and the bottom, depending on how you turn it. Okay? Who can first give me the formula I will use to do sides 1 and 3? Maya? A equals length times width. How do you know to use that formula? Maya? Because it's a rectangle. Bryson, can you tell me the length and the width of box 1? 7 by 3. Do you guys agree? Okay. So we will do 7 times 3. I'm going to draw a squiggly. Is it 8? 1, 2, 3, 4, 5, 6, 7, 8. Yep, I disagree. So 24. Who can give me another set that goes together? Brant? We said 1 and 3, so we're already done with 1 and 3. What'd you say? Okay, he's saying 5 and 6. I'll do that one over here. 5 and 6. What is the area of, or what shape do we have, Kinley? Square. We can use the square formula, or we could use rectangle. Let's do square. What is it? A equals what? Side length squared. What is the side length of the square, Paxton? 3. So I'm going to do 3 squared. What's 3 squared, Paxton? 9. Am I done yet, Kendall? Which ones am I missing?
2 and 4.
Sides 2 and 4. It's still a rectangle. On this one, what's true about these 4? Kinley? Yeah, why are they all the same? Why on this one are all of our rectangles the same? There is a reason. Kendall?
Because if you fold them in half, then if they weren't the same, they'd all wouldn't connect with each other.
Okay, you're right, but there's a reason on this specific problem why all of those rectangles are the same. Because the base is a square. If the base is a square, those are the ones you're going to like, because that means all of your rectangles will be the same. If the base is a rectangle, then you'll have 2 different sets. Now, common mistake answer is 48 plus 9. So 57 is a common wrong answer. Why is 57 not the right answer? Cam?
Because you only found like 1 and 2.
Yeah, we only found 3 sides, so there's different ways you could go from here. Some people like to add those 3 numbers. Let's go ahead and do that. And if we add those, we would get 57. What would I need to do to that number to get my final answer, Briley? You could multiply it by 2. You could add 57. Or you could do another plus 24, 24, 9, 9. You could have doubled here and did 48, 48, 18. There's lots of different ways you can get to the final answer here. You just have to make sure you double all of those at some point. I'm just going to go ahead and add it again. My number is 114. What is my label? Kinley? Oh, it is meters. You're right, because it says square meters up there. Meters squared. Why is it squared? Why is it squared, Emmett? Because you're finding area. Okay? It's just lots of different areas added together. So any of your surface area labels will still be units squared. Parker?
I have a question. Why does it say that if the area of 1 square is 1 square meter?
Because sometimes they might tell you that one of these squares is worth like half.
Oh, I thought it meant like the whole thing.
No. Okay, we're actually going to go down to example 3. They are telling us to find the area of the given cuboid. What do we call cuboids? Callan? Rectangular prisms. Finley, how many sides or faces do rectangular prisms have, or that shape have? How many rectangles do you see? 6. I'm going to number them in a way that makes more sense this time. Okay? I'm going to call this one 1, and I want its partner, or the one that is the same size, to be number 2. Kinley, which one am I looking at? Yeah, the one over here, because if I fold this up, those two would be across from each other. So if I call this one 3, Kanan, which one am I calling number 4? Yeah, the one right there. So then I'm going to call this one 5 and that one 6. I'm just showing you a different way to set up the work. I'm going to write 1, 2, draw a line, 3, 4, draw a line, 5, 6. Who thinks they know where I'm going with this? How can I use that to show work? Parker?
Because some like number one has both the sides right there, but number 2 doesn't, so you don't have to do any work really.
Yeah, I'll just have to duplicate that number. What shape are all of these faces? Callan? Rectangles. So on my 1, 3, and 5, I'm going to write A equals L times W, A equals L times W, A equals L times W. Box 1 or 2, we could use either one. Lena, what are my dimensions for box 1 and 2?
4 times 9.
4 times 9, so I'm going to write 4 times 9. What is 4 times 9, Lena? 36. Now, some people like to go ahead and write it down a second time. Some people like to add 3 numbers and multiply it by 2 at the end. Does it matter?
No.
Nope, I'm just showing you different strategies. Box 3 or 4. Who can give me the dimensions of box 3 or 4? Caden, can you give me the dimensions of box 3 or 4?
6 times 9.
Okay, 6 times 9 is 54. I'm going to write that twice. Now, box 5 doesn't look like it gives us anything, but does it? Emma?
On the side where it said square 1 at the side.
Yeah, it tells me that that's 4, so this side also has to be 4. Abby, how do I get the other side? How do I get this side length? Yeah, if that's 6, that's 6, that one's 6, and that one's 6. So it doesn't matter where you pull it from, but that's one where you have to do a little processing and figure out what is that side length. So this one is 4 times 6, which is 24. Once we have all of them, we need to do what with them?
Add them up.
Add them together. I like to group these two. 6 and 4. 6 and 4 is 20 plus 8. So 8, regroup. 3, 6, 8 plus 10 is 18, 22. Label. Parker?
What would be simpler would this be to multiply the
We said there's different ways to do it. I'm showing you different strategies. I asked for the label.
the label is
Inches squared. Okay, flip your paper to the back side. Now we're about to run out of time for that one. How many work problems would you need to show? Callan? How many faces are there? You would be adding 5 areas together, but Callan's telling me I really only have 2 math problems. Why, Callan?
Because the triangles are all the same and then
Yeah, so let's go ahead and do this one. So that's a 1. I'm going to call this 2, 3, 4, and 5. With this one, I'm going to organize it like this. Finley, what's my formula for area of a square? A equals side squared What is the side length of that middle square, Finley? What's the side length of that middle square? 12, yeah. So our formula would just be 12 squared, which is 144. What other shape do we see, Kendall? Triangle. What is the formula for area of a triangle? Base times height divided by 2. What is the base, Callan? 12. What is the height? 8. It only gives it in one spot. Where's the only spot that it gives it, Logan? On the, yeah, over on box or triangle 5. So this is 12 times 8 divided by 2. Is that 10 important? Nope, that's a diagonal distance. Why do all of these triangles have to be the same height? At least the ones opposite from each other. Cam? Yeah, if they are opposite from each other, they have to be the same height or else they wouldn't come to a perfect point at the top. Okay, so the left and the right have to be the same, the front and the back have to be the same. I haven't showed you this trick yet. I can just do that to make my math simpler. What's 12 divided by 2? 6, and we still have to multiply it by 8. What's 6 times 8? 48. Or you could have done 12 times 8 is 96, divided by 2 is still 48. That only works if it's multiplication at the top. If it's addition, it doesn't work. Now, how many 48s do I have? 4. I'm just going to do times 4. 2. So I get 192. Is my answer 192?
Yeah, no.
What else do I have to do to that, Lori?
Add the 142.
Yeah, I have 192 plus 144. Label? Feet squared. Now, really, what do you have to be good at to find the area of these, Reese? Or sorry, to find the surface area, what do you have to know how to do? Find the area of flat shapes. That's why we spent so much time on that. Now, we do not have time to do example 5. Where do they give us the numbers for number 5? We're just going to get it set up on the net. They give us numbers over here, and we have to apply them over here. So focus on the triangle first. Where will I label the 6 on the triangle on the net? Emma? Like right here. Everybody put a 6 right there because, ooh, hold on. Where did you say? That's wrong. Where did you say? Oh yeah, okay, right here. Yeah, that right there is the 6 because if I folded this out, it would kind of be flapping out there by itself. So what is this distance right here? 8. Think about the 10. It's given here, it's a diagonal distance, so it's not important on the triangle, but Kanan, why is that still important?
On the side of M.
Yeah, it would be the side of M because if this unfolded, it would be that distance right there. So that is 10. Which one are we missing? Paxton? The 9. Where could I put the 9? Yeah, I could put it here, here. Really, it's all of these. We're still missing one. What is this distance and why? That distance and why. And again, this is the spatial reasoning, where if you're not an artistic person, this will be challenging. Brant?
8.
No. Lena?
It's 9.
No.
No.
Abby?
6.
Why is it 6?
Because it's gonna get like folded in.
If you fold that up, that will be the same edge. So those would have to be the same. Okay, flip your packet a whole nother page. Shh. For homework. Okay, for homework. The next page shows a 3D shape and then multiple choice nets. You are choosing which of those options is the net for the 3D shape given, okay? So that one is multiple choice. Even the ones with circles, I want you to try them. I think you can figure it out. Then you have 3 surface areas to find, okay? It gives you the net and the 3D shape. So you're only doing surface area of those 3 shapes where it says surface area of solid using nets. Does that make sense? You have the multiple choice and the 3 surface area problems. Okay, we're going to do surface area the whole rest of the week. Okay, you guys can go. I will see you tomorrow. Have a good day.